Let's check a question I came across. A student asked, a major follower asked that we solve this problem. It is always from Dalton's law of partial pressures. The question reads, just as you can see, a certain mass of gas collected over water at 16 degrees Celsius and 745 millimeter mercury has a volume of 40 cm cube, and they required us to calculate the volume when it is dry at STP. Volume when it is dry. Remember, the water, the gas is collected over water. The gas is collected over water. That is one point you should note. And they said you should calculate the dry gas at STP. And they give us SV, meaning saturated vapor pressure of water at this is what 13 degrees Celsius. So 13.5 millimeter mercury. So let us see how we can solve this little problem. The first thing you must do is there is a structural formula you can use to get the actual pressure of the gas. Because this 75 millimeter mercury, no, the first question you should ask yourself, what parameter do they give? This is pressure. Millimeter mercury talks about pressure. 40 cm cube talks about volume. 16 degrees centigrade talk about temperature. So now there is a formula that I use to calculate the actual pressure of the gas. That is a P total equals P gas plus P water vapor. This is the formula you use to get the actual volume, sorry, the actual pressure of the dry gas. Remember that this pressure here is the pressure of that gas collected over water. So from this formula now, we will be able to get the P gas, which we will use for our calculation. So P total here is what? 745 millimeter mercury. Let me just be adding the unit. Equals P gas plus P water. They gave us saturated vapor pressure of water is what? 13.5 millimeter mercury. And of which we can make P gas the subject of the formula. You can make it the subject of the formula. So that means that, okay, let me just collect like terms. Minus 13.5 equals P gas. So calculator will help us now to get, calculator will help us now. I just did it 745 minus 13.5 give us this 731.5 meters. That is the P gas. Now let us come and see the parameter that's given. But don't forget STP is in the question. It then means that let us bring the parameters given from this question. That means that P1 is what? 731.5 millimeter mercury, which we have calculated. Like I told you, we can't use this one because this one is collected over water. This is the real value we use for P gas. Now, V1 is what? 40 cm cube. Just from the question I'm taking out the distance. T1 equals 16 degrees Celsius. But don't forget that we must convert it to Kelvin. 16 plus 273, which will give us, we will do that one later. We'll do that one later. So now P2 is 760 millimeter mercury. That is the standard pressure. I'll talk more about it. T2 is which one? Okay, Kelvin, 273 Kelvin. That is the standard temperature. And now V2 is unknown. That is the one they asked us to find. How was I able to get all these parameters? From the question. P1. How do I know all these things? In fact, from this one, now STP, it will tell you that the formula you should use is general gas equation. Because in general gas equation, it combines both the Boyle's law, Charles' law, and others. In fact, combination of Boyle's law and Charles' law is what make general gas equation. So now V1 is given from the question. T1 is 16, but we are converting it to Kelvin. If you are converting from degrees Celsius to Kelvin, add 273. But if you are converting from Kelvin to degrees Celsius, minus 273. It's a major conversion factor once we're talking about temperature measurement. Okay, now the P2 is gotten from the standard pressure. I always tell students that why would I use 760 millimeter mercury? Because the first one is in millimeter mercury. That is why I decided to choose 760 millimeter mercury. There are other values of pressure. You can say 1 atm, if you're talking about atmosphere. If you're talking about Pascal, 1.01 times 10 raised to the power 5 Newton per meter squared. And now 760. 760 is also there. So all these things are standard pressure. Once we are talking about STP, they are standard pressure. So assuming that the first pressure is in atmosphere, assuming it is in atmosphere, the B2, which is standard pressure, I would have used 1 atm here. So had it been it is in Newton per meter square, which is Pascal, I would have used this one as my P2, and so on and so forth. Don't forget. Now, let us now apply the formula here should be the general gas equation, which is P1 V1 over T1, which is equal to P2 V2 over T2. This is the formula we are using. This is the formula we are using. Now, let's substitute. Okay, let's substitute. Remember, P1 V1 over T1, P2 V2 over T2. So what is our P1? Our P1 is 731.5. What is our V1? 40. What is our T1? Okay, our T1, add this, add this, add this. Add it. 16 plus 273 is 289K. So it's 289K. Okay, what is our B2? 760. What is our V2? V2 is unknown. What is our T2? 273. What do we do? It's a 289. What do? We cross multiply. We cross multiply. So this thing becomes 289 multiplied by 760 times V2, which is equal to 731.5 multiplied by 40 multiplied by 273. So let's multiply all this. Or we can just say, how do we make V2 the subject of the formula? By dividing both sides by this. So we just simply say V2 equals 731.5 multiplied by 40 multiplied by 273, all divided by 289 times 760. So that is it. Let's just get the use calculator, get all these things, and now get our V2. So if I press my calculator well, when you multiply all this numerator, you will get something like this. You get this value. Now when you multiply the denominator, you get this value. And of which you divide this by this, you get this. So since our first volume, since our V1 is an approximate value, so there's no need. I approximated it to the nearest whole number. That is 36 cm. That is our V2. Just be mindful of what we did. If a gas is collected over water, it then means that that pressure it will have is not the true pressure, it's just the partial pressure. You are going to get the true pressure by using that formula PT equals P gas plus P water vapor. Now from there now you are now going to get, this is the one you use for your calculation P gas. After you must have done the calculation. And now STP, remember to have all these values. And now the standard temperature, standard temperature is 0 degrees Celsius and 273K. These two are, volume has no standard volume. So it's just standard temperature and standard pressure. All these values should be at the tip of your fingers, so that I believe it is now clearer to the person that asked the question. See you next time.